Brought to you by Connect.js, Atlanta's premier JavaScript conference. Sponsored in part by FeatherDirect. Need a mobile app? Contact us for your custom mobile solution.
Is the future of JavaScript. We're going to talk about a little bit about the past of JavaScript and then the future, which is ECMASCRIPT 6. It's called Harmony, and what we're going to get with ES6. So, who am I? Why should you be listening to me? My name is Micah. I'm a full stack developer. I do mostly Rails on the back end, but I'm also comfortable with Node and a lot of other stuff. Do a ton of JavaScript on the front end, from your standard jQuery snarl all up to Angular, Ember kind of stuff. So comfortable on the entire stack. I'm a COFFEESCRIPT lover. That's probably going to come through in this talk a little bit. If I'm writing a new file in JavaScript, it's almost 100% going to be born in COFFEESCRIPT. It's rare that I start a new JavaScript thing. I co-run a small consulting company here in Atlanta that we do all this web development stuff. We'd love to work with people, so if you need developers, please come talk to me. And I also run a podcast that's about designers and developers and sort of the interactions between developers and designers, which I think a lot of, especially the people that work on the front end here, it'd be a good podcast. So what are we going to talk about today? So first of all, brief history of JavaScript and ECMASCRIPT. What even is ECMASCRIPT? Why do we call it that? Who should care? Like why should you even care about this stuff? A quick overview, my favorite new features, when do you get to use it, and okay, that's way too long, what can I do now instead of waiting that long? So what is ECMASCRIPT? So in the past there was JavaScript, and that was the first version that came out with Netscape. And this guy, Brendan Eich, he put together JavaScript and shipped it with Netscape. And then Microsoft launched their own version called JScript, slightly after that. That was sort of the same syntax. It was like, oh, this is a good idea. Let's include this in our browser too. So you have JavaScript and you have JScript. They're basically the same, and then they come together. The titans of industry come together and they decide, like, all right, let's go ahead and centralize on these. But now you've already got trademarks and sort of intellectual property stuff going on. So they can't call it JScript. They can't call it JavaScript. So the standard was ECMASCRIPT, and that stands for European Computer Manufacturers Association. So sort of like ISE or like ISO or IEEE, one of these standards organizations. They have ECMA 262 is where they set down what the actual syntax and all the specification for what we would come to know as JavaScript. And the creator of JavaScript says ECMASCRIPT sounds like a skin disease. So unfortunately, that's what happens when titans get together and fight over intellectual property rights and those sorts of things. But for the most part, if you're reading online and you see something that says ECMASCRIPT, you can just think JavaScript. It gets a little bit weird if you're a Flex or a Flash developer, because ActionScript is also ECMASCRIPT. But for most of the people in this room, I doubt you guys are doing a lot of Flash or Flex development. So if you just read ECMASCRIPT, just in your mind translate it to JavaScript. It's basically the same thing. So quick timeline on ECMASCRIPT. JavaScript in the first ECMA 262 specification was finalized in 1996. Between then and 1999, they had one revision. Then between 99 and 2009, so 10 years there, we were on ES3. Theoretically, in 2009, we switched to ES5. We actually didn't yet, but I'll get to that in a second. In the future, in sort of the near future, we have ES6 Harmony, and people are already talking about ES7, like what's going to come after that. But don't worry about that. We'll all be long dead at the speed that these things move. So what gets added? What happens? I guess it came as a surprise to me to learn that JavaScript actually had versions and that these things were changing. So in ES3, one of the things that was added, one of the big ones, was regular expressions. And I don't know about you guys, but I can't imagine writing JavaScript without access to regular expressions. I do all kinds of things with messing with URLs and all that kind of stuff. So prior to 1999, you couldn't do that. You just didn't have access to the regular expression object. You may notice that there's no ECMASCRIPT 4 up there. So what happened to ES4? Again, when titans come together, nobody can agree on anything. So Google, Microsoft, Netscape, all these guys come together, and there's a lot of infighting over what actually ES4 is going to be. There were claims of you're being too aggressive, you're going to actually break the web, you're going to break backwards compatibility. So ES4 collapses and falls apart. They finally come back together and make ES5, which is actually a much smaller and less, it's much more conservative is what they did with ES5. So what happened in ES5? Well, before ES5, there was no native support for JSON. So sort of the modern web that we talk about now, where you're doing JSON calls back to the server, you could use library support and things like that, but that was not a native or part of like core JavaScript until ES5. In addition, there's like a lot of stuff for array manipulation, map, reduce. You can actually do those natively in JavaScript now, whereas before ES5 you couldn't do that. So I said earlier that we're supposed to be doing ES5 now. We're not. Well, anybody that supports IE8, you don't get map reduce. You don't get those things. Like IE8 actually does not have support for a lot of these array functions that were part of ES5. You get JSON parsing, but not map reduce. So if you think about it, if you are writing code that has to support IE8, you are writing code to a JavaScript specification from the 90s. So that's 15 years in the past is where you are if you're messing around with IE8. Okay, so who should actually care? Who should really care about these different versions? Like, what does it mean to have these different versions of JavaScript, and why should you care? If you love raw JavaScript, if you don't like libraries, if you don't like using jQuery, and you don't want to use things like COFFEESCRIPT, you don't want to use underscore, and you just want to have you and the browser, then this stuff's very important, because these are features that you will have access to that you did not have before. If you're a platform or library developer, like if you want to write your own library and you don't want to, again, you don't want to depend on underscore, you don't want to depend on jQuery, you want to make your library as available to people as you can without forcing them to install all these other things, then this is important to you as well, because like a lot of this stuff you have to shim in or write yourself, and so having the native browser support it makes your job as a platform or a library developer much easier. Finally, if you're a Stack Overflow troll, I don't know if you guys have seen these people, but there's a lot of developers that go on there, sort of new developers that are like, hey, how do I iterate across an array in jQuery? And like the top voted answer is, that's not jQuery, that's JavaScript. So if that's you, if you're that guy, ES6, pay attention closely, because this is a godsend for you. Like, you get to go now and say, well, in ES6, this is how you do it, which is actually, it's a complete non-answer, since that doesn't work in like 90% of the browsers right now. So if you enjoy confusing new people on Stack Overflow, pay very close attention. There's a lot of information here for you. So what about your average web developer, which I assume most people in this room are? Do you really need to know this stuff? And the answer is no, not really. It's important, it's fun to learn, and there's a lot of cool information here, but like, will this actually affect what you do in your daily life in the near future? Probably not that much, because a lot of these features here that you don't necessarily have access to in the browser, you can get them through libraries. One of the big ones that we're going to talk about a little bit is promises. I assume everybody's heard promises at least 100 times this weekend. And there are probably still some people in this room that don't know what they are. That's totally fine. That's not expected. But there's a lot of these features that you're just not going to have access to them, so you're not going to be able to use them natively in the browser, but there are other libraries and ways to get it. So if you don't, I guess part of what I'm trying to say here is I'm giving you permission to not know this stuff. Like there's a lot of stuff that we're all supposed to know in our daily lives and in our jobs, like, oh, you should know this, you should know that, you should know how the rendering engine works. I'm saying you don't need to know ES6. You do not need to know ES6 versus ES5 versus these different things as a web developer. Like, at least not, you don't need to know the core nitty-gritty details. Just know what works in the browser, what the features are that you want to use, and then how to get those through library support or something like that. How often does anybody give you permission to not know anything? So, all right, so 10,000-foot overview. Like, what are some of this new stuff that's coming? I've broken these up into 3 categories. These are just my distinctions, and these don't necessarily cover everything. It's just some stuff that I wanted to get over real quick, and that is, I broke them up into syntactical sugar, things that like just look a little nicer, some object enhancements to sort of core libraries, and then also what I call the big stuff, which are sort of, some of it is sort of syntactical sugar, but it's more like very different ways of thinking and structuring your JavaScript programs. So syntax sugar-wise, destructuring is one. It allows you to return things from array or from functions, or break up objects or arrays in a very nice, easy-looking way. Function parameter default values. So now when you define a function, you can put default values in there instead of using the first couple lines of if x is undefined then this, if y is undefined then this, that kind of stuff. Rest and spread is a way of working with arrays and sort of function signatures where like let's say you've got a function that takes 3 parameters x, y, z, and you've got an array. Instead of passing array, element 0, 1, and 2, you could just pass the array itself and dot dot dot, and JavaScript will be smart enough to unspool that array and use those as the 3 elements of the array. So REST and spread, they kind of work in similar ways for basically handing arrays around in a much nicer fashion. Templated strings, this stuff's great. I use this in CoffeeScript all the time. It's great stuff. It makes your code much more readable. Not all of this quote, space, plus, space, quote, period. You can get rid of all that stuff and have these really nice templated strings. And then fat arrow functions they're a way to sort of reason about what this is, the this keyword in various different contexts. It makes it a little bit easier when dealing with callbacks and where you get lost, like where am I, what is this? Talk about some of these later. So object enhancements. String is getting starts with, ends with, contains some Unicode stuff. So let's all give string a hand for coming into the 21st century. These are things that we've had in other languages for like 20 years. Math is getting a lot of new trig functions, which, as a note, a lot of those are actually implemented in the browsers already. Because some of this stuff was easy. The browser manufacturers could just be like, all right, yeah, a new logarithm function for the math class, sure, I can put that in there. No syntax changes required or anything like that. So number, there's a lot of platform-specific info, things like max safe integer and this kind of stuff, whereas before, we all just sort of live in this browser world. Now that JavaScript's on a bunch of different platforms, you may not have access to 64-bit integers or something like that. So if you're writing JavaScript for some embedded device, this kind of stuff will help out. So more information about arrays, the ability to iterate over arrays and find specific elements, the index of specific elements. If you want to do this stuff now, you should be using underscore. I love underscore, it's a great library. And then set and map and weak set and weak map, these are just higher level data structures. So we're getting access to more data structures than just flat arrays. We've been building sets and maps and things like this ourselves for a long time, and now JavaScript is going to provide those under the covers. And here's what, and again, this is what I think of as the big stuff. Other people will disagree with me. So classical inheritance. If you guys love prototypical inheritance, then you've lost that war. You're going to still get, you can still use prototypical inheritance, but the core JavaScript people have finally realized that there's a lot of people like me out there that just don't get prototypical inheritance, and they're finally giving us access to classes and extends and constructors and those sorts of things. So your JavaScript's going to end up looking a little bit more Java, less JavaScript. Modules. Now this is big, and this should not be controversial at all. The ability to actually break your JavaScript up into multiple pieces. Define it elsewhere, use it here, define it here, use it elsewhere. None of this dumping things into the global namespace kind of stuff. Like, thank God we're getting away from that. Promises. Again, you've probably heard this 1,000 times this weekend. It's just a way to sanely deal with asynchronous events and reason about things that are happening, in sort of an asynchronous way. And then generators are, you'll see the keyword yield a lot with generators. And generators are ways to sort of jump into and out of functions at certain specified points. Like, all right, the function's running, now I'm going to jump out of it, now I'm going to jump back in. And I'll get to generators in a second. There's some really cool stuff you can do with them. Oh, come on. Okay, so we'll go over what I think of as my favorites, or if I were an arrogant person, I would say the best features. And again, these are a few that I wanted to call out that I think are really cool and that are going to be fun to use. Destructuring. So this is one of the syntactical sugar ones, and this just allows you to break up things and then easily talk about them. So in this case, we've got an employee record. We've got 5 elements in the record, but we want to show someone's name. We want to pop up an alert with somebody's first name and their last name. And so destructuring is that second line that allows us to say, like, okay, I care about first name and last name, and I'm just going to break up that employee record. And so what I'm saying is I don't care about these other elements. Just let me assign these 2 parts of the array to these 2 variables. So in the second one, we've got object destructuring, where you can actually take a point, an XY point, and break that up into its individual X and Y and get those variables out. And then in the last part, it's the same. It's object destructuring again, but you use that syntax if you actually want to change the name. The syntax above, you actually have to use the same names that the base object itself has, but down below, you can actually reassign the names. Destructuring is actually really nice to use with functions where you have a function that returns multiple values. So if instead of like breaking up this array like this, if we had like a get employee name and you wanted to return both their first name and their last name from a function, it's really nice to be able to return both of those now and then just have like first name comma last name equals get employee name. Like it's syntactically it looks very nice. So fat arrow functions. Again, I said earlier, it's a way of sort of reasoning about this and where you are in the application. So I don't know if this happens to you guys, but a lot of times I'll be in like a jQuery callback or something like that, and I want to access something from the surrounding context. I'm in a place where this matters to me, and then I drop into a callback, and then I lose access to this because at that point jQuery will reassign this to the element that was clicked on, or the form that's being submitted, whatever event handler you're handling. So I mean, in this particular case, in that top one, I try to do this .val. It's going to be the button that was clicked. Like it's been reassigned in that callback. But with the fat arrow functions, and so you'll see the second one there, it's just you use that, and it's called the fat arrow because it's the equal sign, like equal, and then the angle bracket. There's a thin arrow, which is not really part of the ES6 specification. But anyways, in that one, this is what you expect it to be. Like, so if you're in a jQuery callback and you don't care what the element was and you don't want things being reassigned, you can use these fat arrow functions. This is part of COFFEESCRIPT. I imagine this was taken from COFFEESCRIPT and added to ES6. It's extremely handy. Like if you like working with objects and you like using this, the this keyword in a lot of places, it's really frustrating when this gets reassigned to something else. And so having the fat arrow functions allows you to decide, do I want to keep this as this, or do I want to let this be reassigned? Promises. Okay, who here does not know what promises are and wants an explanation? Awesome, thank you. Thank you for raising your hand. So promises are a way to sanely reason about sort of these asynchronous events. And so our first example up here in the top is we're making an AJAX call back to our server. We're going to save something, and once that finishes, we want to ping Google Analytics and send them a note that says, hey, this document's been saved. And then once that finishes, we want to write out to the console, hey, I saved this and this other thing happened. So that entire function, that entire code section is going to execute, but those callbacks, the functions inside the then sections, those will execute asynchronously when those events actually occur. And so it's, promises are a way to sort of get away from callback hell and just, having like more and more callbacks that you get sort of lost in. They allow you to reason about, things over time. And so in the first one, it's very common that you'll see them with AJAX. You'll also see them with animation. And so in our second example here, I'm going to animate X. I'm going to move horizontally 100 pixels. Then I'm going to move vertically 100 pixels. And then I'm going to print out to the console, hey, I've moved. And so I'll go over and then down is what we're seeing here. In the third example, we actually combine the two promises together. And I'm going to say, all right, I'm going to animate X and Y. And I'm going to do them at the same time. I mean, they're basically happening pseudo-parallel. So in this case, whatever we're animating is going to animate in a diagonal, and then it's going to end up at the bottom. But it's still not going to print out that console log statement until both of those things finish, because we're using promise.all. And that's just going to say, like, all right, wait until all of these promises, wait until all of these things finish, then run this code. So promises are available now in like a dozen different libraries, but and they're really awesome, and I would highly recommend looking into them. And if you're doing AJAX or animation or anything asynchronous, which if you're doing JavaScript you probably are, they're definitely something that you should be looking into. I'll talk a little bit more about them in a bit. So again, classical inheritance. This is big for me. I don't usually end up with like giant inheritance trees and things like that. But at the same time, I understand this better than I do just basic prototypical inheritance. So the ability to have a class that I can instantiate and say like, all right, call the super class, the super class constructor, those sorts of things. That's coming, and it allows you to just think about your JavaScript in a very classical way as opposed to prototypical. So generators, and I'll spend a little bit more time here because these are a little funkier. And what they do is they allow you to jump into and out of a function at specified points. And so this fib here is our Fibonacci sequence. So Fibonacci sequence is a number in the sequence is the sum of the two numbers before it. So your first two numbers are 0 and 1. Then the next one is the sum of those, which is also 1. The sum of those, which is 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. So it's like 0, 1, 1, 3, 5, 8, 13. So it's just the sum of the numbers before it. It's a fun function to use for things like recursion, where you can just build, the value of it is built from the values that came before. And it's also a great example of generators. So generators are shown with this, the star, the little asterisk before the function name indicates that it's a generator. And what we do is we instantiate the generator. It looks like you call it, but it doesn't actually sort of run the function yet. Instead, it sort of instantiates it. And the way that you run the function is by calling next on it. And so a generator, you just call next on it. And what that will do is that it will run the function until it reaches the next yield point. And then it will yield a value at that point. And you can pass things in. This is sort of a simple example. But the way this is going to work, if we look at it, so I'm going to call next. And it's going to start to run the function. It's going to set f1, f2, and then it's going to hit yield f1, and it's going to return 0. But it actually doesn't return 0. It returns this object. The generators return an object that's got a value, which is what's actually being returned, and then a done, which indicates whether or not the generator has reached completion, which in this case, this one will actually never be done because of that while true loop. So anyways, I call next. It's going to return 0 to me. I call next again. It's going to return 1, because it's going to hit that second yield statement. I call next again. Now it's going to go into my while true loop, and it's just going to keep yielding that second statement every time. And I got a little bit fancy here, and I used the destructuring arguments so that you can see I'm actually setting f1 and f2 at the same time on the on the left while I'm monkeying around with them on the right. And so basically, what that statement says is, all right, take f1 and f2, add them together, assign that to f2, and then take f2 and assign it to f1. So you can think of it as like the Fibonacci sequence, as like you're just moving a window down that sequence, with f1 and f2 moving down that sequence, and then you're just yielding f2 at each one of those at each one of those statements. So you just keep calling next on it, and so from a perspective outside this generator, I actually have, you can almost think of it like an array, an infinite array of the Fibonacci sequence, because I can just keep calling next on that generator, and it's going to keep giving me the next value in the Fibonacci sequence. And there's a new syntax that goes along with these generators called for of, and you just say, for variable of, and then a generator, and this one actually uses, under the hood, it uses the done value and that object, and it will just return to you that value. So I can just say for, x of Fibonacci, and then just console log Fibonacci, and that will run forever, writing out Fibonacci numbers. So this is sort of a toy example. Much cleverer and smarter programmers than me have come up with some cool uses for this. We'll get to it in a second. And did anybody see the functional reactive programming talk from yesterday? He was talking about streams and how to set things up as streams. Generators would be a perfect example of a stream. Like this thing will just stream out values every time you call next. And so this is a good example of like, you could hook this up as a stream for what he was talking about with those functional reactive stuff.
Do you know how you have a while and you're yielding inside of that while loop?
Yes.
What if you're iterating over values in like an underscore method, and then you have a callback? You can't yield within that callback because now you're yielding within another function, not in the generator itself. Is there a way to do that?
I don't know. That's a really good question. I don't know what would happen if you try to yield inside a callback. My hunch is that it would actually sort of work the way you would expect it to, but I don't know. That's a very good question. You can actually run these. So generators work in the latest version of Firefox right now, and so if you're really curious, you could take this code, stick it in a callback, paste it into the debug console in Firebug, and we can find out. So I may try that after the talk. It's a good question. So modules. This is another one of the things that I love, and that is it allows you to define things in other places and use them. Basically, if you're writing Node or Angular or anything like that, you've got a lot of code at this point, a lot of files. JavaScript started off as a way to like make menus animate open, and now we're using it to define these giant, MVC applications and those sorts of things. So it's not enough to just have it all in one file anymore. There are ways of defining modules now. There's two sort of competing standards. One's called CommonJS, and the other one's called AMD, Asynchronous Module Definition. ES6 modules is just sort of like a way of saying like, all right, here's going to be the standard going forward. And then, if you want to stick with one of those other ones, you can. But this is just it's just a nice way to break your projects up into different stuff. And I just love this line at the bottom. Like, I love the idea of specifying I'm going to import $ from jQuery. Like, I get to decide it's called $. jQuery doesn't decide that for me anymore. So I just think that's huge for again, like JavaScript. Welcome to the 21st century. Okay, so those are the ones that I think are really exciting. When do we get to use them? So in the browsers, Firefox leads by a huge margin. Firefox is really, blazing the trail on all of these ES6 features, and you can use a lot of them in Firefox today. Promises, generators. I don't think they have support for modules yet, but there's just a lot of stuff you can use. Chrome is close behind with Firefox, and then as one would expect, IE is in the rear. Along with iOS. iOS isn't doing a great job of keeping up either. But IE, it's a ways off for IE. So if you want to know feature by feature, go to this website right here, and it's a compatibility table for ECMASCRIPT 6, and it will show you feature by feature and browser by browser, and it also has Node on there as well. It'll tell you like what is supported now, what can you use, and so you get a much better idea. And unfortunately, you can see from that picture there's a lot of red, and in the IE column there is quite a bit of red. The Firefox column is pretty good. I use Chrome every day, and I don't use Firefox all that much, but I have to say, like, they really are blazing the trail on adding this stuff. In terms of like what's getting added, fastest and soonest, the new math and number features, a lot of those have already been implemented. So if you do, number processing or trigonometry or those sorts of things in raw JavaScript, you can actually access a lot of those math functions now natively. Promises. Unfortunately, promises are one of the first things that are going to be supported by all the browsers. Even iOS, I think iOS 8 has promises at this point. And I say unfortunately because that's one of the easiest ones to get through library support. Like, if you want promises, there's an entire buffet of different libraries to choose from. Generators are actually pretty high on the list as far as like what's coming. Chrome and Firefox both have generators, and Fat, Arrow, and destructuring, those are both coming, fairly soon. And again, Firefox has them already. Things like modules and the classical inheritance, those are sort of trailing behind. So I like to compare this to HTML5, CSS3 in the sense that, like, does this browser do HTML5? Well, it does these three things, but not these other ones. So at this point, and for the foreseeable future, this is the world that we're going to live in, where some browsers do some, no browsers do all, and some browsers do none. So, bottom line, we're going to have flying cars and hoverboards long before there's like native browser support for this stuff. And just to be clear, like, this is actually technically true. Marty McFly arrives October 21, 2015, and that's like almost exactly 1 year from now. Internet Explorer 12, IE 12 may have some support for some of these features, and it is slated for like Q4 2015. So McFly arrives before IE 12. So I hate to be the bearer of bad news. Like, we won't be able to use this stuff natively just in raw JavaScript unless you're willing to say, like, all right, you can't use this on IE. And that's like IE 12. Like, let alone, IE 9, 8, 10, 11. Even the future's not that great looking. Okay. What about Node? So right now, version 10 is the stable version of Node, and it has very few of these features, like, just a couple, smattering here and there. Node 11, if you run it with the -- Harmony flag, you actually get quite a few of them, including what I would consider the killer feature. And Node 12, which is the next stable version of Node, it goes, even is stable, odd is unstable development version. So Node 12, when it comes out, that's going to have a lot of this stuff in it. But So, and again, if there's anybody here that is really tied into the Node community, please let me know when 12 is coming out, because I did a lot of research, and what I found was a lot of stuff from December of last year and January of this year, like roughly a year ago, saying Node 12 is almost here. And now I find a lot of stuff that says Node 12 will be here when it's here. Like, it'll be ready when it's ready. So we've downgraded from just around the corner to it'll be ready when it's ready. So I'm worried. I'm hoping, because I'll get to it here in a second. I would consider, if I was starting a new project today, I would consider using the unstable version in order to get access to this, which is what I would say the killer feature for this for Node is generators plus promises. Why is that? So this is our pyramid of doom. This is our callback hell, and this is where promises come in to save us. Is in this case we want to select a blog post. We want to take a blog post, take all the comments, mark them as accepted, and then send an email to the user saying, "Hey, your comment's been accepted." So this is on our Node server side code. So we gotta select our blog post, then a callback, then select the accepted comments, then a callback. So this is just our standard asynchronous callbacks. It's Node, nothing happens sequentially. As soon as you go to the database, as soon as you do any sort of external stuff, Node is going to throw that on the stack, it's going to wait on it, or I should say wait, it's going to set it aside until it's ready to actually work on it. As opposed to a very sequential, like do this, then do this, then do this. Like it's one of the great strengths of Node is the ability to do things asynchronously and not get stuck waiting on something. You're not waiting on the database, you're not waiting on external APIs. The downside is instead of writing your code sequentially, you have to write your code in this, rightward drift. This is called the pyramid of doom, the callback hell, where it needs to know what code to run once it finishes doing what it's doing. So promises help with this quite a bit. You can deal with this pyramid of doom, but promises plus generators get you to this. And this is, I love this. I think this is really exciting. So what's going on here is there's this Q library. So Q is a promise library. And Q.spawn, and you hand it one of these generators. And basically what's happening here is each yield statement is yielding a promise. So in that first one we're saying, all right, go to the database and select this blog post, but that's going to return a promise. It's still asynchronous. We're still in Node. It's going to yield that promise, and we're going to yield that back to the spawn function. And the way spawn works is it's now going to set this aside and wait until that promise resolves before returning us back into our function and putting that value into the post. So our blog post, so we yield it, we set it aside, everything continues asynchronously, then we assign that value to post, then we move on to comments, and then we say like, all right, now I want the comments, so I'm going to go back to the database again and I'm going to retrieve those comments. So you can just think of each of these yield statements as returning a promise that then spawn is going to set aside and wait until that promise is resolved. And again, I hate to use the word wait because we're not waiting. We're still in Node. We're still doing things asynchronously. The rest of our code is running, we're handling other requests, we're doing all sorts of other funky stuff in our single, very highly powered Node thread. But this just allows us to sort of like set aside, what I like to think of as like an island of synchronicity. Like we get to look at this and think about it synchronously, because that's what we want to do. At least that's what I want to do. I don't want to live in callback land. I want to live in do this, then do this, then do this, then do this. So that allows us to think about this, whereas it actually, we lose nothing. We don't lose any of the asynchronous nature of Node and any of the power there, and instead we just get to think about things synchronously. So, any questions about this? So, once I finally understood this, I was like, this is cool. Like, this is really cool. And if I was to start a new Node project today, and you can use this. The Q library exists, spawn is real, yield works in Node 11. So I would be like, I would, if I was starting a new Node project today and they were like, we're going to go live with it in 3 months, I would be like, is Node 12 going to be out in 3 months? Like, I would seriously consider, and especially if it's just for fun. If you're doing anything for fun, like a toy project, definitely use Node 11 and play around with this stuff because it is cool. Like, and I think this is what we're going to be seeing in the future. And like, there's actually an ECMASCRIPT 7 far future. They're talking about sort of building this stuff in natively to JavaScript itself. So.
You're living through all your comments, so that means it's going to not do it in parallel. Is there
Probably. Yeah, you're right. I mean, for one,
This is the drawback, right? We start thinking that doing it in order and we lose the benefit of parallel.
that's true. There's probably a way to. So I mean, the question is, we're looping through the comments, and that's kind of inefficient. Like we're doing one comment at a time, and then we're sort of like yielding on that single comment. It would be nice if we could somehow spool it out so that we're like, all right, let's retrieve all of these comments. Instead of yielding, 1, 2, 3, 1, 2, 3, 1, 2, 3, we'd want to yield 1, 1, 1, 1, 1, 1, 1, 1, like that. So, yeah, it's a good point. If we start thinking sequentially like this, you don't want to think too sequentially. You do want to retain some of the abilities that you get with sort of asynchronous nature. Never forget, you are in asynchronous land. All right, so do we want to wait until this happens for us to be able to use this stuff, until we can like rocket to the moon and fly our jetpacks around? I don't. I want to be able to use this stuff today. So what are some ways to get around the fact that this is all just a fantasy right now? Promises. You can use promises today in any number of libraries. If you are using jQuery and you're doing Ajax, you are already using promises even if you don't know it. I know Ember has promises built in. Angular has promises built in as well. They use something very similar to this Q library. If you're in Node, you can, Q seems to be very popular in the Node community. So you can use promises today. They're going to be implemented in the browsers very soon, but again, it doesn't matter. You can use them today with these libraries, and you should be using promises today. Like they can, even if you don't want to go to that yield craziness that I had up there before, you can use promises to get out of callback hell and reason much more easily about sort of these asynchronous events. CoffeeScript. A lot of the stuff that was shown here, things like destructuring, fat arrow, a lot of the syntactical sugar can already be done in CoffeeScript. Templated strings, these sorts of things. I love CoffeeScript. I'm also a Rails guy, so it's not a huge surprise. CoffeeScript is huge in the Rails world. I know it's not big in just the JavaScript world in general, but come join us on the dark side. and one thing that I will say is like the last holdout that I had with CoffeeScript was I don't want to be down the road 5 years from now dealing with machine-generated JavaScript. Like if I use a CoffeeScript compiler, that's a machine that's generating this JavaScript. I don't want to be dealing with just ugly, variable names that I don't understand and just JavaScript that's spooled out. Run a CoffeeScript compiler on some CoffeeScript and look at what's generated. It's better than the JavaScript that I write by hand. Like it actually is. The variables are easy to understand. It's very easy to follow. So I use CoffeeScript every day, and I still have to debug the JavaScript that's generated in the browser. It is easy. It's not a problem. It's not, you don't get lost in between like, oh wait, it was compiled and now it looks like garbage. It's not like minified, uglified stuff. It actually looks like good JavaScript. So I love CoffeeScript. If you're interested, please come find me. We will talk in secret. I won't let anybody else know. Like. So, if you want to use modules, today and break your code up into different sections, and you can actually use the ECMASCRIPT 6 draft specification. It's still a draft. It hasn't been fully finalized and everything yet, but you can use the draft specification for breaking your code up into modules. And so the ES6 module transpiler allows you to define, like, all right, this code lives here. These are the parts of it that I want to export to be used in other places. And so you can write what is technically ES6. And if you try to run this in any of the browsers or anything like that, it won't work. But then you use the transpiler, which is a build tool that you run on your JavaScript before you load your JavaScript into the browser, and it will convert it to sort of what I was saying before, like CommonJS or AMD are these two sort of competing specifications. So you can choose whether you want it to output CommonJS or AMD. I have used this. I used this on an Ember project where it was Ember and CoffeeScript, and it was very smooth. Like, if you are already using any sort of intermediate compiling step, if you're using a minifier or an uglifier or anything that like takes multiple JavaScript files and combines them together, if you're already doing that, adding something in like the transpiler is not that big of a step. And if you're not doing that, I would start to look into it. Like the world of being able to just put all your JavaScript in one file, that's going away. Like we're leaving that behind. That's a good thing. Finally, if you're real brave, Google has a thing called Tracer. And the Tracer, you know, it's got a lot of ES6 stuff in it. And it's almost more defined by what it doesn't have. It has generators, it has modules, it's got arrow functions, classical inheritance, all this different stuff. You can use this Tracer compiler to basically write ES6 style JavaScript that then gets compiled down to ES5 compatible JavaScript. So you write ES6, run the Tracer compiler on it, and that gives you a .js file that you can then run in Chrome or Firefox or whatever. You can try it out online. There's a demo online that you can use to just paste JavaScript into and see what the Tracer compiler is going to do. Like I said, CoffeeScript compiler, it makes stuff that looks pretty good. I took that Fibonacci generator function and I stuck that into the Tracer compiler. I could not understand what was going on. It was this giant switch statement, and it was just very confusing. So I would be very hesitant before using something like this on something that I knew was going to be deployed in production that I would have to then debug in production. Like I don't think based on what I saw, with the test that I did, it's fun to play around with. It's cool to try. Like, let me try the future of JavaScript and use this Tracer compiler on it. But if you have to debug it, it's going to be awful. So I don't think I'd mess with that. So let's assume that you're willing to, dip your toes in and get wet. Is it safe? I would say, especially like on the node side, the biggest threat that you're going to have is with the code that you write. The biggest threat that you're going to have is a small syntactical rewrite. These things are actually draft specifications. They haven't been fully, nobody's 100% agreed that this is exactly what generators are going to look like. This is exactly how modules are going to work. But they've been working on this for years, and we're much closer to what would be considered like a final specification, and this is finally how things are going to work. So the likely bad outcome that you have 2 years down the road, when things are finally all specified and everybody agrees, is a small syntactical rewrite. You may have to change a few statements, of how you import a module or how you define a promise or something like that. It's unlikely at this point that there's going to be a giant semantic shift of, generators don't work this way anymore, they work a different way, or modules don't work like this anymore. So if you do decide to jump in and get your feet wet, besides the practical considerations of how am I actually going to run this today, in the future, you probably, you're not going to be the guy that's left hanging where, the road diverges and you're on this path and you've written a ton of code that no longer goes this way. We're at a point now where it looks like things are not going to semantically change all that much. And again, on the node side, on a new project, I would probably start with Node 11. If it's a toy project and these sorts of things, like if you're doing giant, enterprise stuff, or for, a big client or something like that, probably Node 10, stay safe, just use promises without the yield. But I thought that yield stuff was just so awesome. So go ahead, get in the water, try out CoffeeScript, try out the various compilers. The ES6 module compiler, that one I'm very pleased with. And I would say, if you're writing a big project, go ahead and see about pulling in that ES6 module compiler so that you can then break your project up into different modules and, import them piece by piece as you want. I'm a huge fan of the module compiler. So start using the cool features that you want, and see how they clean up your code, see how they, affect the things that you're trying to do. Pull in some libraries pull in one library for promises. Just choose one and stick with that. And look into things like Grunt and these other task runners to include stuff like the ES6 module transpiler. Get comfortable with these intermediate steps that take your JavaScript and do something else to it. So, because I think that world's coming. That's all I've got. Does anybody have any questions? I don't know much about TypeScript. TypeScript is a sort of another competing thing similar to CoffeeScript. It's a it's a higher order language that gets compiled down to JavaScript. Exactly. It looks a lot more JavaScripty than CoffeeScript does. So yeah, like you said, it's a superset of JavaScript. So I don't know that much about it. But if CoffeeScript makes you want to kill yourself, like look at TypeScript. It's a little bit more JavaScript-like So.
I think at the end of July, actually, TC39 did finalize the module spec, so that's a done deal. Like, that's not changing as far as I know.
Okay, so he said, in the back he says that the module spec has actually been finalized, so that's not going to change, which is good. So I thought it was still a draft specification, but that means go ahead and use the ES6 module transpiler with no worries about in the future of even having to do like a small syntactical rewrite. You'll be good there, and eventually, once that's all supported by everything, you can just pull out the transpiler, and everything will just continue to work as it is already. Other questions, other thoughts?
Is there any pointers about when you use a native promises instead or full active queue or something?
Say it again. It's a polyfills for promises.
Yeah.
In what environment?
Well, that's the point, right? If I'm running in the browser, I don't know what the environment is. I don't know if the program class obviously is there. I'd love to use the native promises. I think they're probably faster. If they're not there, I still would promises.
I don't know. I don't know if there are any, like, I would imagine that the promise libraries like Q would be sort of the most forward in terms of like introspecting on what the browser is doing under the hood. So that's what I would just suggest with promises. First of all, I would suggest if you're already using something that has promises built in, just keep using whatever it is. Like if you're on Angular, just use the Angular promises. I'm not a big fan of, hey, I'm a Rails guy. I don't like getting off the rails. So if you're using jQuery and jQuery has promises for Ajax, don't try to reinvent or pull out the jQuery promises and put in your own favorite new one. Just assume, I guess I would say, assume that the library authors are going to do their due diligence in the future, and then slowly knock out those supports as the browsers like add that in natively. So I could be wrong there, but.
I don't mean to have you, but definitely don't use jQuery promises. If you do that, they're broken. They do not work.
Really? Okay. So the advice is wrap jQuery promises and Q promises. Like every one of them? Like Ajax promises? Wow.
I don't want to do it all, but yeah,
All right, I will look into that. I've used jQuery promises and had no problems with them, but I don't do a lot of really advanced stuff. So, more questions, more thoughts? Is anybody excited by this? Anybody see anything that was like, wow, that's really cool, I'm excited? Okay, well, we got a couple. Anybody that would start up a new Node project in Node 11 in order to get access to that yield stuff? All right, good. Don't blame me when you're like, this isn't stable, this doesn't work. Okay, well, we can call it there. Thanks, everybody, for listening. Hope you had a good time. Hope you learned something.